So this presentation is about Zener diode circuits. Zener diodes are a different type of diodes compared to what we have just covered. Those were rectifier diodes. Ang ilang main purpose is to switch or to pass through current in only one direction. So not so with the Zener diodes. What's the difference between the previous diode that we have and this one, Zener diodes? So for one thing, Zener diodes conduct in both direction. So mga pinakauna nga po siguro characteristic sa Zener diode. Zener diode conduct in both direction. Both positive and negative mo conduct siya. If it is forward biased, meaning the Zener diode could be forward biased and reverse biased. In forward bias mode, it can conduct current. In reverse bias mode, it can also conduct current. So, dili siya intuitive compared to what we've learned before na kung reverse bias is i-block niya current. In this case, current will flow in both directions. So, in forward bias, or before that, this is the schematic symbol for our Zener diode. Wala siya regular diode pero na ay horns, na align. Wala siya regular diode. Okay. But may extra lines right there or horns to denote na Zener diode na siya. So, may someone nag-form siya letter Z. Z. Paspason og do pwede nga na. So, yung positive terminal is not anymore here, unlike sa rectifier diode, but here. So, kung asa yung horns, itong positive and mo negative. And current will flow in this direction. We call this one IZ. If na-satisfy ang condition na BZ. So the same gyapon sa regular rectifier diode na naging satisfy ang voltage drop in this manner. Current will flow downward. So pwede lang na ito i-think class na ang kalahian ng ani sa diode is ang ihalang position sa symbol. Current will still flow downward. Ang polarity will still be plus minus. Pero ihalang symbol is pasaka. Okay? So na lang, wala na siyang difference in terms of initial na analysis. Now, what would happen if we'll connect the Zener diode in the same manner sa pag-connect nato sa rectifier diode? What would happen? Muna nga atong kuan, di ba? Ito sa klase. So if you connect our Zener diode in this manner, the same sa regular rectifier diode, so Zener diode niya because of this symbol, it will act normally, Wala lang siya gyapog normal junction diode or normal rectifier diode. So in any case, siya mag-act as normal diode. Normal diode. And yung voltage drop is still 0.7 volts. Okay? So wala na. Kung yan na ito pag-connect sa Zener diode, wala na ito i-take advantage yung Zener diode na capability. Pero mas useful siya in this manner. No? Kung balo na to. So if this is our circuit now, if this is our circuit, i-connect na to ang diode in Zener diode in that position, mag-conduct yapon siya og current. No? So, may current mag-flow there, napoy current mag-flow here, napoy current mag-flow in that direction. No? But, dili na 0.7 ang voltage drop. It will drop a voltage of VZ, and it is always given. In actual, where can we find VZ? Same yapon. Could be found in the specification sheets. No? VZ in spec sheets. But if dito mag-refer spec sheets and mag-solve ng mga problems, always given na siya. Unless our problem is a design problem, kita mag-determine sa VZ. So, in both cases, the Zener diode will conduct current. So if you try to look at this one, in forward bias mode, current has conducted. Conducting current. In reverse bias mode, nag-conduct po siya. No? But na ay portion na zero iyahang current. No? So I equal to 0. And when is that? No? When is that? When VZ is not yet satisfied. So it will conduct in the reverse bias mode only if VZ is reached. In the same way sa forward bias. So forward bias lang is 0.7 ng gihapon. So VZ is much higher than that. It could go as high as 1 volts, 3 volts, 5 volts, 21 volts. No? Relatively higher gid siya compared sa 0.7. So let's try to solve some examples. No? Few examples na siguro. This one, how about this one? So we have an LED actually there. No, we've never covered LED before. But LED is the same lang gyud siya sa analysis sa LED is the same sa regular junction diode. It's just that lahi iyahang voltage drop. So let's say our LED has a voltage drop of only 1 volt. So given ng gap na siya. So ato LED, that direction, atong silicon diode, that direction. Notice, ang atong mga Zener diode is ilahang symbol is pasaka. So di nga matter, di ba? That's what I've said. Current will still flow downward. So we could solve now for VO1 and VO2. So to solve for VO1, pwede na tayo mag-KVL. Ano? Okay? First, ato lang sa siguro i-solve ang diode voltage drop for the resistor. No? So let's say this is BR. So using KVL in that direction, downward, KVL ka dito. KVL is 40 minus VR minus voltage drop ni LED, 1 volt, minus Zener diode 1, 6 volts, minus silicon diode 0.7, minus Zener diode 2, 3.3. Notice, given ang mga Zener diode voltages equal to 0. Therefore, VR is equal to pila man eh. This is 4, 10, 11, so 40 minus 11 is 29. 29 volts. Sakto ba? Please confirm my answer down if this is correct. So to solve for VO2, pwede tayo mag-KVL. Sakto? 29?
Yes, sir.
Okay, thank you. So pwede tayo mag-KVL in this direction to solve for VO2. KB alta diha. 40 minus VR of 29 minus LED nga 1 minus VO2 to 0. So VO2 di is equal to 30 volts. So no, 40 minus 1. Ano? I don't know, sorry. 13 eh. So 10 ba? 10 volts. Yeah, that's correct. Last is mag-KVL para makuha si VO1. Pwede ra dire, no? Sugod sa sugod. O pwede naman po sugod kang VO2. KVL ta diha. KVL ta in that direction. VO2, which is 10 minus 6 volts ni Zener diode 1 minus VO2. VO1, sorry. 0. 10 minus 6 minus VO1 equal to 0. Therefore, VO1 equal to 2. These are our final answers. Even if dito mag-KVL, 4 volts at makuha. So VO1 minus 0.7 minus 3.3. Okay. Is this clear? Any questions? Basta nga yung given, then Zener diode, sa inside naging siya. Straightforward ang solution. Ang treatment is the same as the series diode circuits that we've learned before. For as long as, again, the Zener diode is naka-reverse bias, no? Kung gusto na ito i-determine ang state sa mga diodes, the LED is forward, the silicon diode is forward, the 6 volts Zener is reverse bias, the 3.3 volts Zener is also reverse bias, pero no matter, mag-conduct ang current gap sa Zener diode even if reverse bias. Okay. So sige, next example daw. What about this one? More complex na siya, but this is just to prove a concept, no? So in this manner, our Zener diode acts as a protection circuit actually, you know. Zener diode protects the system. This system, whatever that may be, no? Maybe more delicate na siya na system, might be a computer system or a control system that requires a constant voltage of 20 volts. If the Zener diode is connected in this manner, nakaparallel siya sa isa ka system. If Zener diode is in parallel with a device, no? Pwede resistor, pwede load, pwede, in this case, a system. It acts as, and this is the main purpose of the Zener diode, it acts as a voltage regulator. Tumogit niya ang main purpose why the Zener diodes exist. Zener diode, or iyang main capability is voltage regulation. I-regulate niya ang voltage to a specific value, which in this case is 20 volts. So ang output waveform, most probably the question for this problem is what is the output waveform? As we've learned before, rectifier man niyo, kung tangtangon na to ang Zener diode, half-wave rectifier naman siya. So, current cannot conduct in the negative half cycle. So, join na nato daan sa negative half cycle. Yeah, no need for computation or analysis. Zero na gina siya daan. Zero na. How about for the positive half cycle? If regular ni siya na rectifier diode or rectifier circuit half wave, then wala nang Zener diode. Yeah, yan na lang ta. The same sa ito na-learn ganina. But tungod kay na naka-parallel sa system na 20 volts na Zener diode, it will regulate the voltage to that point only. So, ang itsura sa atong kuan supposed to be ingani, no? But i-clip away na nga portion. Clip, although ibangid na to nagamiton nga term kay that's used exclusively for clippers. So, na-regulate niya to that value, to that constant value. And what value is that? 20 volts. So in this manner, our Zener diode has regulated the value that is delivered to the system at only 20 volts. So karon ipadayon nun, yan ang output waveform. So 20. So no need for further analysis. Ma-predict na nato sa ang behavior sa system just by looking at it. So because the Zener diode's main purpose is to regulate voltage, mas mo focus ta more diha sa atong analysis sa Zener diode circuits kay wala na may other circuits na magamit mo ang Zener diode, no? And this is a very trivial circuit for Zener diode. We do not normally use Zener diodes that way, but we use Zener diodes as voltage regulator. So the Zener diode as a fixed the Zener diode as a voltage regulator connected to a fixed source and fixed na load. So, kanilang siguro ato i-solve for this morning. Notice, the Zener diode is connected in parallel with our load. So we label this one as our source resistor. Source resistor. And this is our load resistor. Okay, so source resistor and load resistor. And then pag Zener diode gani class, if we refer back to our characteristic curve, notice this portion, di ba? Na ay portion that the current is 0 volts. No, sorry, 0 amps, 0 amperes. Meaning, we need to determine if there is enough voltage drop sa kaning portion to turn on the Zener diode, or to reverse bias the Zener diode. So how do we do that? First step actually is to solve for the voltage divider voltage as if the Zener diode does not exist. No? So first step actually, solve for VL as if there is no Zener diode. Muna first step. We solve for the voltage drop across the load as if there is no Zener diode. Then we compare. We compare it to where? To the given 10 volts. So natin two outcomes, possible outcomes. If VL is greater than VZ, therefore IZ is 0. Or the Zener diode is not forward bias nor reverse bias. So the Zener diode will is as if it doesn't exist. But if VL is less than VZ, okay, so VL is now equal to VZ. So na-regulate ang voltage, na make constant the same aning situation. The voltage drop across the system is 20 volts all throughout. The same here. No? Let's try to solve this one. No? For RL is 1.2 kilo ohms. Yeah, 1,200 ohms. So, solve for VL. So, I hope kadungdong pa mo sa voltage divider na formula. It's VS, VL is equal to VS R2 over R1 plus R2. So VL is equal to play VS on the circuit 16 times 1.2K over R1 is 1K, diba? Plus 1.2K or 2.2K. So how much is VL class? Kasi maka-solve. May calculator.
8.72, sir.
8.72. So VL is 8.72 volts. Case A or case B? Case A or case B?
B, sir.
B, no? So, in this case, wala nag-work atong Zener diode. It's not forward bias, but dili po siya reverse bias. So, wala siya nag-conduct of current. No? So, pwede natin i-diretso o conclude. Therefore, Zener diode is off. It's as if atong circuit kay walay protection na gi-set. No? Wala siya voltage regulator. No? Wala gi-protect sa atong Zener diode ang atong load na 1.2K. No? So, diretso na nato og conclude ni. No? Wala na tayo mabuhat ni. IZ equal to 0. So, wala. As if ang atong circuit kay wala lang siya regular nga voltage divider circuit. Walay nag-exist nga protective device, no? So wala. Dili enough ang atong load voltage. So di na to tama. Actually, if makita nato nga gamay ang load voltage, no? Wala tayo mabuhat ana. Unless we'll change the value of our load. No? So what if our load is now 3K, no? 3,000 ohms. No? So balik ko na to. Change na to itong load to 3K. So 16 times 3K plus 1K plus 3K. 12 volts. 1/4 man eh. 3/4 man eh. No? 12 volts, correct? Sakto? Because VL is now 12 volts, therefore, new VL is equal to VZ is equal to 10 volts. So, because our VL is greater than, so case B siya, no? VL is greater than, sorry, VL is less than VZ. VZ is greater than VL. VL is now equal to VZ. So, na regulate, no, or na may constant ang voltage across the load to only 10 volts all throughout. The same here, the same sa atong sorry. Same here. So bisan pag mabot na siya og 21, 22, 23 taman 30, 40, 50, 60, di na mag-matter because pugong, no? May constant sa atong Zener diode ang voltage across the load or across the system. So VL is now 10 volts. So if we'll withdraw our circuit, it will look like this. $1K, $3K, 10 volts. 10 volts, not anymore 12 volts. Okay. So because load voltage is 10 volts, could you guess pila ang source voltage sa source resistor? Or voltage drop across the source resistor? If 16 volts ni, and then atong load is 10 volts, what is the voltage drop across R1? Would like to guess, no, without using the calculator. If mag-KVL ta, in that direction, V1 is now equal to 6 volts. So 6 volts na siya. Could we solve for the currents? Yeah, we could. Current across the load is equal to I equals to V over R. So 10 divided by 3K. Ilan eh? 10 divided by 3,000. 3.33. How about I1? Current across the 1K resistor. So 6 volts divided by 1K. 6 milliamperes. Therefore, if mag-KCL ta at this junction, I1 is going in that direction, IL is going that direction. Therefore, we could solve for IZ. IZ is equal to IL minus I1 by virtue of KCL. Therefore, IZ is equal to 6 minus 3.33, 2.67. Okay, and that's it. Uh, Any questions?